Welcome to our lesson on building bulletproof security for AI systems. In today's interconnected world, the integrity of our AI applications isn't just a feature, it's a fundamental requirement. By the end of this session, you'll gain a deep understanding of why security testing is absolutely critical for any AI system deployed in production. We'll dive into the core concepts that underpin robust security, like authentication, authorization, and continuous vulnerability assessment. You'll also explore the essential architectural components that make up a comprehensive security testing framework. Finally, we'll discuss how to seamlessly integrate these security practices into your existing CI/CD pipelines and ensure vigilant monitoring once your systems are live. Get ready to elevate your security game and build AI applications that stand strong against real-world threats. Why is security testing so non-negotiable for AI systems? Think of a major streaming platform processing billions of API calls daily. A single authentication flaw could expose millions of user accounts. Or consider a payment platform that runs tens of thousands of security scenarios with every deployment, catching critical vulnerabilities before they ever see production. This isn't just about finding bugs. It's about building unwavering confidence that your system can withstand sophisticated real-world attacks. We're talking about preventing data breaches, safeguarding sensitive information, and blocking unauthorized access to critical functions. At its core, security testing encompasses three vital areas. First, authentication, ensuring only legitimate users get in. Second, authorization, making sure users only access what they're allowed to use. And third, continuous vulnerability assessment, proactively scanning for known weaknesses like injection attacks or misconfigurations, integrating with known vulnerability databases to keep your system ahead of emerging threats. These components work in concert to create a formidable defense. Now, let's peel back the layers and look at the core components that make up a robust security testing architecture. At the heart of it all is the security test engine. This engine is the brain, orchestrating every security testing activity, managing test execution, collecting results, and generating actionable reports. Think of that as the central command for your security operations. Next, we have the Authentication Test Suite. This suite rigorously covers all login mechanisms, session management, password policies, and token lifecycles. It ensures that only valid users can gain entry and that their sessions are secure from start to finish. Complementing this is the Authorization Framework, a sophisticated role-based testing system. It verifies that authenticated users can only access resources they're explicitly permitted to use, simulating scenarios like privilege escalation attempts to catch any gaps. Finally, the Vulnerability Scanner acts as your automated penetration tester. It continuously scans for common weaknesses like SQL injection, cross-site scripting, and security misconfigurations, integrating with known vulnerability databases to keep your system ahead of emerging threats. These components work in concert to create a formidable defense. Moving from theory to practice, how do these concepts translate into real-world systems? Major platforms like a popular code hosting service run hundreds of thousands of security tests daily, detecting suspicious patterns in unauthorized access attempts long before they impact users. Your own platform, whether it's a quiz system or a complex AI service, can implement similar patterns. Automated security testing, real-time threat detection, and comprehensive audit logging that scales from a few users to thousands. However, security testing in distributed systems introduces a new layer of complexity. With microservices, attacks can target multiple components simultaneously, requiring coordinated testing across authentication services, data storage, and processing layers. We need to simulate multi-vector attacks like simultaneous login attempts or cross-service data leakage. Beyond testing, robust systems require continuous production security monitoring. This means tracking authentication failures, suspicious access patterns, and potential breaches in real time, generating alerts for security teams, and even automatically applying defensive measures when threats are detected. It's about being proactive, not just reactive. We've covered a lot of ground today. You now understand that building truly secure AI systems means going beyond basic checks. By applying these principles, you'll be able to develop a comprehensive security test suite covering authentication, authorization, and vulnerability assessment, running automatically. You'll also have the foundation for a real-time security dashboard and a complete audit trail system, giving you full visibility and control over your system's security posture. Crucially, you'll integrate these security tests directly into your CI/CD pipelines, ensuring that every new deployment is automatically vetted for vulnerabilities before it ever reaches production. To solidify your understanding, here's a self-assessment challenge. Imagine you need to implement a complete security audit system for a fictional e-commerce platform. How would you design it to detect weak password policies, session hijacking attempts, SQL injection vulnerabilities, unauthorized admin access, and data exfiltration patterns? Think through the steps, the components, and the monitoring required. This exercise will help you apply everything we've discussed to a practical scenario. Your journey to building bulletproof AI systems has just begun.